Okay, hit enter, and when it stops turning on, we'll change them. Because unfortunately, I mean, AAA batteries are expensive. We've got 24 times 4, so that's 96 batteries. They will all be changed by the end of the year. All right, guys. What we're talking about today is augmented matrices, so matrices. We're going to talk more about matrices in 1.7 on Monday, talking about doing some operations with matrices. But a matrice is a rectangular arrangement of numbers. The dimensions of a matrix are rows by columns. So I always start in just kind of keeping track of it. I start in the top left, count how many I go down, how many rows I have down, and then go over to the right. So if we look at this here, so 4, 0, so 2 rows and 3 columns. So we would call this a 3 by 3. Questions on this here? Each of these numbers is an element. It's an element of the matrix. A matrix derived from a system of linear equations, each written in standard form with the constant terms on the right, is an augmented matrix. For example, the system below can be represented by the given augmented matrix. So you don't have to write this in. So as we write it in, we'll have each equation in the form of x, y, z equals a number. And we take the numbers in front of it. So the first equation is 5x plus 3y minus 2z equals 1. So the coefficients would be 5, 3, negative 2, and then 1. And we would do that all the way through. So let's flip the page. Let's look at this here. So we're going to write this as an augmented matrix. So for our our two equations we have is y minus 2x equals 1, x plus 3y equals 12.
May I have your attention? May I have your attention, please? We are now ready for junior girls to go to the library for their pictures. Junior girls. Thank you. Thank you.
All right. Here we go. We're going to look at these problems here, augmented matrices. So augmented matrices, we're going to want to rewrite these as a matrix. Now the first thing we need to do is make sure that each equation, one, has all the variables on one side, and our coefficients, our constant terms, our numbers without a variable on the other. So if we look at both of these here, the top one, x and y are on the same side, bottom one, x and y are on the same side. However, this top equation, we have y first instead of x. So we need to rewrite it. So we're going to switch the x and y. So the negative 2x is going to go first, and our positive 1y is going to go second, because we want each of these equations written in x, y, or x, y, z, if it has z. So whenever we switch it, if there's a negative sign in front of it, it keeps it. If there's a positive sign or plus in front of it, it keeps it. Now, since there wasn't a sign written in front of y, it's understood to be positive. Okay. Now, our matrix, our augmented matrix. So we're looking at this first equation, and we're going to take the numbers in front of the variables first. So the number in front of x is negative 2, so it goes first. Our next number, the number in front of y is 1. There is no z, but so we go to what it's equal to is. So the first row, negative 2, 1, 1. Questions on this so far? So what would our next row be? There's the augmented matrix. So it's a 2 by 3 because we have 2 rows and 3 columns. And we write that as 2 by 3. There's the full answer. That's it. That's it. That's all we have to do. Questions on this here? Let's look at the next one. So They gave us these two equations, and we want to write it in an augmented matrix. Now, the first equation, the y and x are flipped, yes? So we would rewrite it as what? And we can easily switch them because the x and y are on the same side of the equal sign. If they're on opposite sides of the equal sign, we have to add or subtract it from both sides to move it. Yeah, we can't just pull it from one side to the other. We have to add or subtract from both sides. Now, our coefficients going across the top, our numbers going across the top would be 4 for x, 3 for y equals 13. Our bottom equation. And this here would be a 2 by 3. 2 rows, 2 columns. That's it. Questions on this here? We ready? So number of rows, so we go down. So there's 2 rows. Because 1, 2. And then here we have 1, 2, 3. So 2 by 3. So we're just stating the dimensions of the matrix.
So you don't even have to really solve it, you just have to figure out the equation, like the end equation.
Yeah, because we're reorganizing it because we need it in standard form. Standard form is x, y, and then z if we have it. Make sense? Yeah, and the reason that we do it x, y, z is based off a whole set of math called number theory, which states that all variables in an equation need to be ordered in alphabetical order and descending power. So if there was x squared, it would go first. Now, let's look at this one here. So the bottom 2 equations, we'll look at them first. So the middle one, we have 9x plus 3y equals 3. Variables are on one side. They are in alphabetical order, yes? X, y. The bottom one, we have x, y, z. X is first, y is second, z is third, yes? They're both equal to a number, so we're good there. If we look at the top equation, we do have x, y in the right order, equals 7 minus 2z. Z is on the wrong side. So we have to get z to the other side. I'm going to write it over here to the side. So unfortunately, we just can't pick up the negative 2z and put it on the other side and say minus 2z. Here,
May I have your attention? May I have your attention, please? This is the last call for pictures for anyone from 9th through 11th grade. Last call for pictures for anyone from the 9th through 11th grade. Need to go to the library at this time.
so we would add
Thank you.
2z to both sides, because if we look at the left side, negative 2z plus 2z, negative 2 plus 2 is 0. So that would remove the 2z from the right side. But we now add it to the left side. Now, since none of these are like terms, we'll have 3x minus 4y plus 2z equals 7.
Oh, so you pretty much are just moving it up by making it look like an equation.
Yeah, so I just wrote it to the side so that we can make that movement and not have to try to squeeze it between those 2 equations. So to move a variable from one side to the other, we're going to add or subtract it to get it to move over. So our new equation here is 3x minus 4y plus 2z is equal to 7. So if we write our matrices, the first equation, our numbers going from left to right would be 3, negative 4, 2, 7. Our next equation, 9, 3, because this equation does not have a z, yes? If one equation in our sets has z, the others have to have it as well. So since the top equation had z, the middle is going to need z. If one equation has z, the others need it. So since there's not a z written, it's understood to be 0. And our last equation, 2, 2. Our dimensions would be 3 by 4. Questions on this here? We ready for the next one? Okay. So we have these three equations here. We want to write it, the augmented matrix, state the dimensions. So if we look at the first equation, is it in the form x, y, z equals number?
Yes.
How about the second one? How about the third one? Do we need to do anything to them? No. So we can go on and just write the matricing. So our first row would be what? 8. Then we'd have 2, 4, 2, 1, 4, 2. 9, -7, -3, -6. What are the dimensions? 3 by 4. Questions on these here? Oh, it's just the same problem. Do we need to see another example of one of these?
I need the softball girls to meet me in Coach Kendall's room at lunchtime. Softball girls meet me in Coach Kendall's room at lunchtime. Thank you.
So, let's look at this here. Solving systems of equations using technology. So we've solved systems, 1-5. We spent 2 days solving systems of equations, yes? We can use these augmented matrices to solve them. Now, if I look at this here, this matrix, in the first column, we had our x's. Second column was y, third column was z, and they were set equal to a number, yes? So if we rewrite out this first row, it says that we have 1x plus 0y plus 0z is equal to negative 1.4, yes? So when we simplify that, we get x is equal to negative 1.4. Because 0z and 0y, 0 is gone. We're just left with x, yes? So seeing that, so the middle row, 0x plus y plus 0z equals 5.2 is just telling us y is 5.2. And the last one is telling us z is equal to 16. So the solution for this given system is the ordered triplet, negative 1.4, 5.2, and 16. So we can actually use these augmented matrices to solve a system of equations. We ready to see how we do this? So, solving systems using technology, using these graphing calculators, are these 4 steps. 1, we need to write the augmented matrix. 2, we need to put it in. And 3, tell the calculator to put it in reduced row epsilon form, the form we just saw, that diagonal of 1s. So, we have this here. We have these 3 equations. X plus y plus z equals 2. 2x plus 3y plus z equals 3. And x minus y minus 2z equals negative 6. So if we wrote this as an augmented matrix, because we do have x, y, z, it's all set up correctly, our first row, the numbers would be what? 1, 1, 1, 2. Our next one would be? And the last one would be? And what would the dimensions be? 3 by 4. Okay. So grab the graphing calculator and turn it on. So I will tell you this here, the 3 lines, the key press history will be showing up here. So that might be helpful. All right. The batteries might be dead. So if they're dead, go on and grab a different one. We'll change them. I'll change them out here in a bit. There you go. You can use this one for now. Now, first thing we're going to hit. Second matrix. Yeah, I'll take it. Second matrix. So x to the negative 1. Second. So second. So did we all get this screen? Yep. We get here. Yes? We all have this screen? So the numbers next to A, B, C, D can be different, or you can have nothing, but we see for the most part a screen that looks similar to this here, yes? Yeah. What's next to A, B, C, D doesn't matter, but you do have names, math, edits, and then A through I going down. Yes? Go press the right arrow over 2. We want to go over to edit. And then hit enter. Because what this is telling us and what it's allowing us to do is to put the numbers into the matrices. Yeah, so there's most likely numbers already put in. Now, our dimensions, we said it was a 3 by 4, yes? So that augmented matrix we wrote out, we're going to put it in. So it was 1, 1, 1, 2 for the top, yes? So we'll type 1, 1, 1, 2. After you type each number in, you can hit enter. It will move it to the next spot. Once you get, and we're going to type the whole thing in. Let's see here, where are we at? Trying to read upside down. Almost there. Oh yeah, so 1, 1, 1, 2, 2, 3, 1, 3. So yours is not going to show the whole screen. It's going to, yeah. So as you keep putting them in, yeah, so 3 by 4. So now I start putting, so we're putting in one element at a time. So 1, hit enter. Now put the next one in.
So 3 by 4. And then you put in the numbers that we just which is 1, 1, 1, 2.
So you have to use the negative. You can't use the minus.
2, 3, 2.
Is everybody able to get it all put in? Yes? Yep. Next to 0, or next to the decimal at the bottom. Everybody able to get it all typed in? Once you get it all typed out, second quit, second mode. Second mode. Yep, so we quit out of this. because we put the matrix in. If you try to do anything after this, it's going to try to put it in one of those spots. So we have to quit out. So second mode, second quit is going to take us back to the home screen, back to our, right next to second. Yep, there we go. So we're back to here, yes? Okay. Now second matrix. Yeah. So once we get it typed in, we go second quit. So now we did second matrix to pull this back up. Now we're going to go one over. So we're going to have math highlighted at the top. Scroll up or down and find RREF. And once you find it, hit enter. So you should have this here. Now don't hit enter yet, because this is reduced row epsilon form. And the calculator is going to do one more, RREF. So we need to tell it what matrix to apply this to. Okay? So second matrix, one more time. Now this first row is recalling the matrices, like actually applying functions to it. Now we put it in A, so we can just hit enter. You're good?
I just got the number 10. What do we do?
Second, quit, second mode. Second matrix. Go over one. And now we're going to find enter.
I did it.
Second matrix. Enter. One more time. Hit enter again. Okay.
Press the wrong one. Apparently. It's RRF.
Second matrix. So we'll finish this on Monday. Second matrix A.
Oh, right.
Thank you.